students, this is our last lesson for indices and surds. Okay, so today we are going to learn, okay, to solve equations for surds again, but it will be of a different technique than the last lesson. Now, before we go into that, there is a skill that you have to recognize, okay, for the next section of solving. That is, it's quite similar to what we have learned about comparing the left-hand side and the right-hand side of identities in the chapter of polynomial. Okay, but in this case, it is for surds. Okay, so if you are given, okay, a plus b square root k is equal to c plus d square root k, by comparing, okay, I can say that, okay, the constants are equal, and because the surd is also equal, so I can say that b is also equal to d. Okay, so if I were to rewrite it, okay, I can hence say that a is equal to c and b is equal to d. Okay, the comparison is made possible because of the format of both the left hand side and the right hand side, okay, having the same surd. Okay, so an example, if I have 14 minus a plus 2 square root 5 equals 7 plus b square root 5, okay, so because the square roots are the same, okay, so I can see that b is 2, okay, and 14 minus a is equal to 7, okay, and hence I can solve a, okay, to be 7, okay. Now, based on this understanding of comparing, okay, I'm going to apply this skill to the next kind of question that we're going to see, okay. Now, if you look at example 12, okay, for this question, let's read the question together. It says that given that a and b are integers, find the value of a and b in this equation, okay. Now, notice that it is only one equation, right? One equation is given, and yet we are expected to find two unknowns. Okay, so two unknowns, but we are only given one equation. Okay, so we have learned that to find two unknowns, okay, we have learned under simultaneous equation that to find two unknowns by right, we should have two simultaneous equations to be solved, right, to get two unknowns. But in this case, it's only one equation that is given. So we are going to use the technique that we've learned about comparing left and right to create two equations for ourselves in order to solve for the two unknowns. Okay, so I'm going to do a demonstration on what to do. Okay, basically for this question, we realize that, okay, my a is hidden in the bracket, right? Okay, and my b is on the other side. Okay, but we are not ready to compare yet because for us to compare, it has to be in this form. But on one side, we have two brackets that is clearly not simplified yet. Okay, so we are going to first expand the brackets. Okay, expand the brackets using my rainbow method. 3a minus 4a square root of 2, and I have plus 9 square root 2 minus 12 square root 2 times square root 2. Right, there are two square root 2's. Okay, so the other side is the same. Okay, and if I were to simplify a little bit more, okay, I have a constant here, 3a minus 12 times 2, which is 24, and I have my surd terms over here. Okay, now notice that, okay, I purposely write it in this form, that, okay, this constant here, and then the surd terms are at the back. Okay, so this is convenient for us to see the comparison. So if I were to compare and equate both sides, okay, by comparing, what we can see that, okay, the constant terms are here, okay, and the coefficient or the terms with square root 2, okay, are over here. So I'm going to do a comparison to find my A and B. So 3A minus 24 is equal to negative 18. So this is my first equation. And I have negative 4A, negative 4A plus 9, which are the numbers in front of square root 2, be equal to B. So this is my second equation. So this is how I made myself two equations to find A and B, because the question only started with one equation, and yet we need to solve two unknowns. Okay, so using this technique, I can make myself two equations, and now I'm going to solve them simultaneously. For the first equation, if I were to just simplify it, 3A will be equal to 6. So A is equal to 2. Okay. Now for the next equation is for me to find B. So if I were to sub, I have to sub A equal to 2 back into equation 2. Okay, sub A equal to 2 to equation 2. So I'm going to get negative 4 times A, which is 2, plus 9 equal to B. So B is equal to 1. Okay, so here are my answers. A equal to 2 and B equal to 1. Now, how can we check if my answers or if your answers are correct? Okay, so again, I can always sub back my answer. Sub A equal to 2, okay, and B equal to 1 back to my question. Okay, so on the left hand side, I have A plus 3 square root 2. Okay, so A is 2. I have these two brackets at the start, and I'm going to evaluate them just using my calculator. Okay, if I were to evaluate them on the calculator, okay, I'm going to get negative 16.58, 5786, and so on. Okay. Now on the right hand side, okay, the side with B, I'm going to substitute my B back. Okay, but B is 1, square root 2. And I'm going to evaluate this on the calculator again. Okay. Now if it works out to be the same as the left hand side, then I will be correct. So in this case, if I work out my calculator, it is really negative 16.585786 and so on. Okay. So because the left hand side is equal to the right hand side, then I can confirm that A is indeed 2 and B is indeed 1. Okay. Now let's look at the next question. Okay, so looking at this, again, we want to find A and B according to the question. Now, do you know how we can do this question? Okay, basically to compare, we shouldn't have brackets on one side. Okay, so my first step is going to be to expand to remove the bracket. Okay, to multiply or expand the brackets. And then the other side, there's nothing much to do. Okay, and then I can continue to simplify. 5A, okay, this one, I can rewrite it as negative 9B, and then my third terms. Okay, so now I'm ready to compare, okay, because I have the third terms to be the same, okay, so I can compare the constant terms on the left hand and right hand side and the third terms, okay. So I'm going to form my two equations again in order for me to find that two unknowns, A and B. Okay, so this is my equation 1, and okay, looking at the third terms, I will have my equation 2. okay, because the third terms, negative 3a plus 5b equal to negative 4. Okay, so the next thing is, of course, to solve these simultaneous equations to get a and b. Okay, so sorry, okay, there's a error here. Okay, so if I were to solve this equation, okay, you can use different methods. I'm going to use substitution method here. So I'm going to make equation 1, okay, becomes a equal to 6 plus 9b over 5. And I'm going to label this as equation 3, sub equation 3 to 2. Okay, so I will have negative 3, 6 plus 9b over 5 plus 5b equal to negative 4. Okay, so if I were to continue to solve this, my b will be equal to 1. Okay, so if I sub b equal to 1 to my equation 1, a, or my equation 3, sorry, a will be equal to 6 plus 9b over 5, which is equal to 3. Okay, so once again, you can always check your answers by substituting a and b back to the question. Okay, and make sure that the left hand side is equal to the right hand side for checking. Okay, now let's look at the next question. Now the next question looks a little different from what we have, right? Okay, in this case there are no brackets. Okay, in this case there are no brackets. However, it is still on finding a and b. But the issue here is that my a and b seems to be at the denominator. So how is it that I can, okay, because in order for us to compare, okay, we look back at the scenario, it has to be, okay, everything at the numerator for us to compare left and right? Okay, but for example 12c, we see that we have a third fraction on one side and the other side has no third fraction. Okay, so this is just a little manipulation trick, which is to do a cross multiply. Okay, so I will have a plus b square root 7 multiply with 4 minus square root 7, which is equal to 2 plus 4 square root 7 times 1, okay, which is just 2 plus 4 square root 7. So notice how I cross multiply, and here we go again. Okay, we end up with the same format as part A and part B. So once again, okay, it is about expanding the brackets. Okay, expanding the brackets. And then we are going to do a left and right side comparison. Okay, so constant compare with the constant. Okay, constant equal to the constant on the other side, and third terms. Okay, there's no need to write the square root 7 because the other side also has some. Okay, so what we are looking at are the numbers in front of the third equal to 4 on the other side. Okay, so here we go again, having two simultaneous equations for two unknowns to be found. Okay, so if I were to solve this, okay, so please do a simultaneous, and you're going to get a equal to 4 and b is equal to 2. Okay, I'm just going to give you the final answers here. Okay, you can do your own simultaneous at your own time. Okay, but the procedures are about the same. Okay, the main idea is just to simplify until you are ready, okay, to make a comparison on the left and the right hand side. Okay, and this technique has to be done because given one equation, I am expected to find two unknowns. Okay, so comparing in this way gives us two equations to find two unknowns. Okay, now let's look at the next example. Now the next example is a very different form of comparing. Okay, now let's look at what the question says first, and then we will decide on what to do. So basically, example 13 gave you this identity. Okay, square root a plus square root b squared is equal to a plus b plus 2 square root ab, right? Okay, but the aim here is to find out the square root of 17 plus 6 square root 8 without the use of calculators. Okay, so let me just briefly write what it means. Okay, so basically they want you to find square root 17 plus 6 square root 8. Okay, so that is the main aim of the question. But they mentioned that it has to be done without using calculators, meaning they want the exact answer. Okay, that means they want the exact answer. And they somehow give you one more set of clue. Okay, now if you were to have to evaluate this whole thing without calculator, okay, the idea here, combined with the clue that they give, okay, is that if we are able to make 17 plus 6 square root 8 into a perfect square, okay, then we'll be able to square root the square term and get the result of the square root. Okay, now, but how can we express 17 plus 6 square root 8 into a perfect square? So this one requires the help of a condition that they give. Okay, so I'm going to start the question first, and then let's decide on what to do next. Okay, so in order for me to make it into a perfect square, I have to first look at the terms that I've given and compare it with this that's given. Okay, so this a plus b is supposed to be my 17, right? Okay, the constant that is without surd. And this 2 times square root ab is supposed to be my surd term, which is 6 square root 8. Okay, now, but there is an obstacle that we have to get through. And that obstacle is that, okay, notice that this term, it starts with 2, right? But the question gave us 6 at the start. So is there a way for us to make 6 square root 8 into 2 square root something? Okay, so I'm going to try to force 6 square root 8 to become 2 square root something. And then later I'm going to figure out what's my a and b. And then I'm going to make use of the making of the perfect square. Okay, so I can rewrite square root 8 as square root 4 at square root. Okay, in fact, please notice something. Okay, since I want to have a start with 2, okay, so I'm going to straight away break up 6 into 2 times 3 square root 8. Okay, so intentionally, I want the 2 to be in front. Okay, and everything else, I will push it to the back first. Okay, so the surd is still there. It's just that now we have a 2 at the front already. Okay, but this 3, I can rewrite it as 9, square root 9, and then with the square root 8 from the question. Okay, now this intentional move is such that I can express the surd now in terms of 2 square root 9 times 8. Okay, now if I were to compare the question, what can we say about what is A and what is B? If we say that A is if we say that A is equal to 9 and B is equal to 8, does it tally for 17? Is 17 A plus B? If it is, okay, then I can safely say that 17 is 9 plus 8, and then I have a 2 square root 9 times 8. So my A is 9, my B is 8, okay, and hence I can re-express what is in the square root as square root A plus square root B squared. Now, the idea of making whatever that is inside the square root square, okay, is back to the aim of the question here. is for us to, without calculator, square root this entire term. Okay, and if it's not a perfect square, there is no way that we can not use calculator to get a value, exact value. Okay, so now I have made use of the condition that is given by the question, and I made myself a perfect square. Okay, in the square root. So now without calculator, I can say that the square root of the term that are given in the square root will be square root 9 plus square root 8. Okay, so I can still reduce square root 9 to be 3, and square root 8, I can rewrite it as square root 2 times 4, or 3 plus 2 square root 2, okay, because 4 square root 4, okay, is 2, right? Okay, now, how can I check whether my answer is correct? Again, you can always use the calculator. Okay, check. Okay, if you use the calculator, what is this number? And just tally with the calculator too that it is the same as 3 plus 2 square root 2. Okay. Now let's look at the last question. Now the last question is actually an O-level question. Okay, so this is the code in 2004 paper 2. Okay, question number 2. It is given that example 14 was the question, and let's look at the question together. So this question again, it gives you equation here. Okay, and without the use of calculator, they require you to find two unknowns. Okay, so again, two unknowns to be found, but only one equation given. So the technique is to again compare on both sides, but the issue here is that one side I have square root, and the other side somehow there is a fraction. Okay, so the present issue here is more of the square root, so I'm going to square both sides first. Okay, if I were to square both sides, okay, I will get a plus b square root 3 equal to 13 over 4 plus square root 3 squared. Okay, and so I will get 169 over 4 plus square root 3 square will be 4 square, a square plus 2ab plus b square. And so I can simplify a little bit for the denominator, and I will get it to be 19 plus 8 square root 3. Okay, now what happened is that, okay, I still cannot compare directly because on this side it's a fraction and my cert is in the denominator, but in this case it is a numerator, so I'm not ready to compare yet. Now there are a few methods to go about this, okay, before we reach to comparing. Of course, you can always cross multiply, and then we will later do a comparison again. But in this case, it is actually easier to just keep a plus b on the left hand side. Okay, we just keep a plus b here, and later we can compare directly. But on the right hand side, I'm going to use another method. Okay, and actually this method is what we have covered under rationalizing. Okay, so if I were to multiply up and down with a conjugate of the denominator, okay, rationalize, okay, rationalize 19 minus 8 square root 3. Okay, so up and down I will multiply with the same thing. Okay, this is rationalizing. So this way can help me remove the cert from the denominator and bring it up to the numerator so that later I can compare. Okay. Now if I were to continue, okay, so a plus b square root 3, pretty much this side is remains as it is, but it's the other side that has lots of simplification to do. So I'm going to now, okay, do this rationalizing a plus b, a minus b. So I will have 19 squared, a squared minus my b squared. Okay, And if I were to calculate it, 19 square minus 8 square root 3 square, okay, this entire thing at the denominator, okay, is going to be also 169, okay. So I can therefore, okay, I can therefore reduce, and hence a plus b square root 3 will be equal to 19 minus 8 square root 3. Okay, so notice that the surds are the same. So therefore, I can do a comparison left and right and say therefore a is equal to 19 and b is equal to 8. Okay, so you have already learned how to check your answer. Okay, so basically I can always replace a and b with 19 and 8 back into the question. Okay, do a square root and make sure that it is the same on the left hand side and the right hand side. Okay, so that's it for indices and surds. Complete your workbook A for indices and surds, and also your holiday assignment. Okay, by 23rd March, which is your school reopen date.